Layer 7, the topmost layer of the OSI reference model, is the application layer. This layer relates to the service that directly support user applications, such as software for file transfers, database access, and email. In other words, it serves as a window through which application processors can access network services. A message to be sent across the network enters the OSI reference model at this point and exits the OSI reference model's application layer on the receiving computer. The lower layer supports the tasks that are performed at the application layer. These tasks include general network access, flow control, and error recovery.
Presentation layer, Layer 6. The presentation layer defines the format used to exchange data among network computers. Think of it as the network's translator. When computers from dissimilar systems such as IBM, Apple, and Sun need to communicate, a certain amount of translation and byte reordering must be done. Within the sending computer, the presentation layer translates data from the format sent down from the application layer into a commonly recognized intermediary format. At the receiving computer, this layer translates the intermediary format into a format that can be useful to that computer's application layer. The presentation layer is responsible for converting protocols, translating the data, encrypting the data, changing or converting the character set, and expanding graphics. The presentation layer also manages data compression to reduce the number of bits that need to be transmitted.
Layer 5. The session layer allows two applications on different computers to open, use, and close a connection called a session. The session layer is responsible for managing this dialogue. It performs name recognition and other functions such as security that are needed to allow two applications to communicate over the network. The session layer synchronizes user tasks by placing checkpoints in the data stream. The checkpoints break the data into smaller groups for error detection. This way, if the network fails, only the data after the last checkpoint has to be retransmitted. This layer also implements dialogue control between communicating processes, such as regulating which site transmit, when, and for how long. Layer 4. The transport layer provides an additional connection level beneath the session layer. The transport layer ensures that packets are delivered error-free, in sequence, and without losses or duplications. At the sending computer, this layer repackages message, dividing long message into several packets and collecting small packets together in one package. This process ensures that packets are transmitted efficiently over the network. At the receiving computer, the transport layer opens the packets, reassembles the original message, and typically sends an acknowledgement that the message was received. If a duplicate packet arrives, this layer will recognize the duplicate and discard it. The transport layer provides flow control and error handling, and participates in solving problems concerned with the transmission and reception of packets. Transmission Control Protocol (TCP) and Sequence Packet Exchange (SPX) are examples of transport layer protocols.
Layer 3. The network layer is responsible for addressing messages and translating logical addresses and names into physical addresses. This layer also determines the routes from the source to the destination computer. It determines which path the data should take based on network conditions, priority of service, and other factors. It also manages traffic problems on the network, such as switching and routing of packets and controlling the congestion of data.
Data link layer. The data link layer sends data frames from the network layer to the physical layer. It controls the electrical impulses that enter and leave the network cable. On the receiving end, the data link layer packages raw bits from the physical layer into data frames. A data frame is an organized logical structure in which data can be placed. The data link layer is responsible for providing error-free transfer of these frames from one computer to another through the physical layer. This allows the network layer to anticipate virtually error-free transmission over the network connection. Usually, when the data link layer sends a frame, it waits for an acknowledgement from the recipient. The recipient data link layer detects any problem with the frame that might have occurred during transmission. Frames that were damaged during transmission or were not acknowledged are then resent.
Physical layer, Layer 1. The bottom layer of the OSI layer reference model is the physical layer. This layer transmits the unstructured raw bit stream over a physical medium, such as the network cable. The physical layer is totally hardware-oriented and deals with all aspects of establishing and maintaining a physical link between communicating computers. The physical layer also carries the signal that transmits data generated by each of the. This layer defines how the cable is attached to the NIC. For example, it defines how many pins the connector has and the function of each. It also defines which transmission technique will be used to send data over the network cable. This layer provides data encoding and bit synchronization. The physical layer is responsible for transmitting bits 0 and 1 from one computer to another, ensuring that when a transmitting host sends a 1 bit, it is received as a 1 bit, not a 0 bit. Because different types of media physically transmit bits, light or electrical signal differently.
That's all from us.